and welcome to the first module of database development. In this lecture, we are going to discuss about a generic information system and the importance of database in computer applications. An information system accepts data from its environment, processes the data, and produces output data for decision making. It interacts with the environment, and the database in it provides a long-term memory. Database is a key component, and other components include inputs, processes, software, hardware, outputs, and the people. Here in this example that is showcased, it's a student management system where the inputs are exam appearance, exam schedule, and the outputs can be exam score grades and reporting dashboard to show a history of the grades of students. Database here provides a structured information and historical records are all organized inside this database. So what is a database management system? A DBMS is a software system that orchestrates data. It allows users to create, define, manipulate, and manage databases. Please note that database is different from a DBMS. Database management system can be Oracle, Postgres, or SQL Server, and all of these are databases. Think of it as a librarian organizing a vast collection of books. The key roles of DBMS include data storage, data retrieval, and data security. So let's talk about the types of data. Number one is structured data, which refers to the information that is organized and formatted in a specific way, following a predefined model or schema. Structured data has a well-defined structure where each data element is assigned a specific data type and it fits into a predefined table, field, or column. Examples of structured data include financial records, customer information in a CRM system, or inventory data. Then we have semi-structured data, which is a type of data that does not have a rigid structure like the structured data, but it contains some organization and tags that provide it partial structure. It contains both structured and unstructured elements. Semi-structured data often has predefined formats but also allows for variations and flexibility within that format. For example, we can have email messages, log files, and XML documents. In an email message, the structured elements are from, which contains who is sending the email, to the recipients of that email, and body. But the body can have anything inside it which is unstructured. Next we have fully unstructured data. The unstructured data refers to the information that does not have a predefined structure at all. It lacks a consistent format and does not fit neatly into any traditional database or spreadsheet. It is typically in the form of text, images and audio files, videos, social media posts, or documents. It is vast in quantity and often generated with a very high velocity. Analyzing and extracting insights from unstructured data can be challenging due to its lack of organization. However, advancements in natural language processing, machine learning, and text mining techniques have made it possible to derive valuable insights from the unstructured data. Like I mentioned, the examples could be text, image, audio files, and social media posts. In summary, the structured data has a predefined and organized format, semi-structured data has a partial structure, and unstructured data lacks a predefined structure or organization. Each type of data requires a different approach for storage, analysis, and processing. So let's talk about the type of databases. Several factors influence the choice of database, such as the data type and structure, querying mechanisms, latency requirements, transaction speeds, and intended use of the data. It is important to mention two main types of databases here. Number one is relational and other is non-relational database. Relational databases, also referred to as RDBMS, build upon the organizational principles of flat files or spreadsheets, with data organized into tabular format with rows and columns following a well-defined structure and schema. However, unlike flat files, RDBMS are optimized for data operations and querying involving many tables and much larger data volumes. Structured Query Language or SQL is a standard querying language for relational database. And then we have NoSQL databases, also known as not only SQL. Non-relational databases emerged in the response to the volume, diversity, and speed at which the data is being generated today. mainly influenced by advances in cloud computing, Internet of Things, and social media proliferations built for speed. Non-relational databases made it possible to store data in a schema-less or free-form fashion. It is widely used for processing big data. So let's see the examples for relational database, which can be MySQL, Oracle database, and Postgres. For the non-relational database, we can further have classifications for a key value pair database, and the examples for this would be Redis and DynamoDB. We can have document-based databases, and MongoDB is an example for that. Then we can have column-based databases, and HBase and Cassandra fits into that category. We have also graph-based databases, which have Neo4j and Cosmos as examples. Going into the detail of each type is out of scope for this course, and we are going to focus only on the relational databases and data modeling for relational database development.